Alec, thanks very much for letting us into your domain at the University of Leicester. This is where it all began, just a couple of yards away from where we're sitting right now. That was where you discovered a hugely important thing.
Well, first of all, welcome to Department of Genetics at Leicester University, and my remarkably scruffy office.
I didn't want to say.
It's still very much a working office, and I'm still a working scientist. But yes, this is where the story of DNA fingerprinting started. And in fact, I inspected our first DNA fingerprint round about 3 yards away from where we're sitting.
And, you know, a eureka moment it was when you came into the lab after a weekend to discover something had been brewing in a dark room. Just talk me through what happened.
Okay, well, it was the morning of the Monday the 10th of September 1984, and it was 9:05 when I took this little bit of X-ray film out of a developing tank, walked into my office with it, had a look at it, and I thought, good grief, what a horrible looking mess. And then, within seconds, suddenly realised we'd accidentally developed the world's first DNA fingerprint.
What did you think you were doing in there? What were you expecting to see?
Well, what we were trying to do is to break into bits of DNA, this is the genetic material in humans, which varied a lot between people. Why we were interested in that? As basic research tools to try and map human chromosomes, identify genes involved in inherited disease. What I saw immediately in these patterns, and purely by chance, in our very first X-ray film, we had 3 people, in fact my technician and a mum and a dad, and we could see that all 3 people could be readily distinguished with these highly variable patterns in a single test, and you could also see how the technician's DNA fingerprint was sort of composite of characters inherited from mum and from dad. So it literally took about 30 seconds for the penny to drop, that here was a potential for DNA-based identification, something completely new. And not just identification, but also looking at family relationships as well. So within minutes, we're having sort of forensic-y thoughts, we're having paternity testing thoughts, but also, very excitingly on that, again, totally by accident, we had a whole series of non-human DNAs on there. So we had DNA from a rat and a mouse, a seal, a baboon, even tobacco DNA, and everything was produced in these DNA fingerprints. It's absolutely amazing. So suddenly, what I saw opening was a door that I didn't even know was there, which was a door opening into the world of DNA-based identification. And that really was very exciting. And I just stress that we saw this pattern first at 9:05 in the morning. At 9:04, I didn't have a single forensic thought in my head. At 9:06, I most certainly did. And come the afternoon, I mean, we were doing, I was running around the lab, pricking my finger, making sort of mock crime scenes, putting blood stains on it. Because the very obvious question is that, can you get DNA from a crime scene sample, like an old blood stain? Nobody knew. We had no idea whether DNA survived for any sort of significant length of time. So the afternoon I had a sort of very sore finger and spots of blood everywhere.
You must have been delighted though. You must have been absolutely ecstatic. This is huge.
Was with caution, with great caution, because we could see the potential, but we could see right from the outset that first the technology had to be improved dramatically before you could ever possibly use it in case work. And the second issue we see is whether anybody would take the slightest bit of interest in this. And let me tell you, just I think it was maybe a month or 2 after that first DNA fingerprint, I gave a seminar, informal seminar, lunchtime seminar in this department. So I just discussed about the biology of the bits of DNA that we're looking at, and then speculated at the end that, yeah, maybe we could use these DNA fingerprints, for example, to catch rapists from semen left on victims. At which point, about a third of the audience just burst out laughing.
It was so outlandish to suggest
they thought I'd completely lost the plot. And I have to tell you, that was a very good stimulus for me to move things forward. So.
Weren't you angry, though? You thought, hang on, you're not seeing this yet. You can't understand the application yet.
Yeah, well, it was just so arcane that I mean, nowadays, everybody knows that you use DNA to catch criminals, but once upon a time, there was no DNA in forensics, nor was it obvious that it would ever be applied.
You've just said everybody knows DNA, they know about fingerprint, but actually people don't really understand what DNA is. You're going to have to do the science bit now and tell us exactly what we are talking about here, because we know about the double helix and Crick and Watson, but we really don't know what we're talking about. So I'm leaving it to you.
I think most people have actually got a sort of fairly good idea what DNA is. DNA is just a chemical substance present in virtually every cell in your body, and it contains the genetic instructions for making you.